Okay, let's talk about transformations of graphs. So for transformations, the main 5 transformations that you need to know is translations, scalings, reflections, modulus, and reciprocals. Okay, so let's talk about translations first. Okay, so translations are shifting the graph, right? When we translate, we are just moving the graph left, right, up, down. Okay, so the first thing we can talk about is vertical translations. That means we are moving the graph up and down, right? Which means we are doing things related to my y-axis. Okay, so if we were to look at vertical translations, let's say I have the graph of y equals to x plus 2, for example. Okay, let's say we want to translate this graph, okay, by 3 units in the positive y direction. Okay, first of all these statements, okay, you need to state what type of transformation it is, how many units, and what direction is going in. Okay, so graphically, what is happening is that this graph is going to move 3 units up, right? Because there's a positive y direction. Okay, so the graph is going to move up by 3 units. So if you were to look at the graph here, right, okay, it's moving up by 3 units. Okay, but mathematically, we always need to do the opposite. So if I'm moving up by 3 units, what I'm going to do is I'm going to replace y with y minus 3 instead. Okay, so always do the opposite for the math, like the math part of it. Okay, so if you replace y with y minus 3, you will eventually get y equals to x plus 5, which is this equation of the graph here. Okay, so on the other side, if I were to do the same thing again, if I were to translate the graph of y equals to x plus 2 by 3 units in the negative y direction, so again, state my transformation, state my units, right, and which direction I'm going in. Okay, so graphically, I'm going to move my graph down, okay, by 3 units. And again, I'm going to do the opposite with the replacement. So I'm going to replace y with y plus 3. Okay, and eventually I will get this graph here, right, with the equation y equals to x minus 1. Okay, so that is what translations are, right? I'm moving the graph up, down, left, right. Okay, so if I'm moving up and down, it's called vertical translations. So on the other side, if we have horizontal translations, means we are moving the graph left and right, okay, and we are dealing with our x-axis. Okay, so the same similar example. If I have a graph of y equals to x plus 2, okay, let's say I translate this graph by 2 units in the positive x direction, right? It means I am moving my graph 2 units to the right, okay? So what I'm going to do is I'm going to replace x with x minus 2 because the replacement is always the opposite of the English statement, okay? So eventually I'll get a graph of y equals to x. And on the other side here, if I were to translate this graph by 2 units in the negative x direction, okay, I'm going to move my graph 2 units to the left. Okay, I'll do the same steps and I'll end up with a graph like this. Okay, so that is basically the first type of transformation that you have, which is translations. Okay, the next type of transformation that we have is called scaling. So scaling is just making the graph bigger or smaller while still keeping the proportions the same. Okay, just like how we have vertical and horizontal translations, we are also going to have vertical and horizontal scalings. So let's take a look at vertical scaling first. So I'm keeping my same graph of y equals to x plus 2. Okay, and in this case, we are going to scale the graph, okay, parallel to the y-axis by scale factor of 5. So in our statement, again, we need to state our transformation. In this case, we need to say parallel to what axis. So if we are scaling or we are doing a vertical scaling, we are going to need to say parallel to the y-axis. Okay, and we also need to say a scale factor of something. In this case, because we have a scale factor of 5, okay, graphically, what this means is every single y value that we have on this graph is going to be multiplied by 5. Okay, but in the same vein, okay, we're going to redo the opposite replacement, which means we're going to replace y with 1 over 5y instead. Okay, and if we do that, this is the equation that we get. We get y equals to 5x plus 10. And if you sketch out the graph, yes, you'll realize that, okay, it's whatever I've mentioned. Okay, all my y values are going to be multiplied by 5. So that is what a vertical scaling is. Okay, so keeping the same pattern, okay, for horizontal scaling, okay, we're going to scale the graph parallel to the x-axis this time. And let's say we have a scale factor of 1 over 5. Okay, so just like how we did the vertical scaling, this means that all my x values now are going to be multiplied by 1 over 5. And in terms of replacement, we just replace x with 5x instead. Okay, So if we replace x with 5x, we get y equals to 5x plus 2. And this graph, okay, you realize that again, okay, all my x values are going to be multiplied by 1 over 5. Okay, moving on to our third type of transformation, okay, it's going to be known as reflections. So when we reflect something, okay, it's basically how you draw mirror images in physics in secondary school, right? So we're going to have either our x-axis or our y-axis be our mirror plane. Okay, so if we're doing a horizontal reflection, my y-axis here is going to be my mirror, right? So you should expect that everything on the right is going to be reflected to the left, and everything on the left is going to be reflected to the right. Okay, so that's what's happening graphically. My y-axis is going to be my mirror plane. In terms of the mathematical section or how we write our equation, okay, what we're going to do is replace x with minus x, right? Because for example, if something was had an x value of 1, right, you should expect it to be minus 1 now when you reflect it in the y-axis. Okay, so here's what it looks like, okay, graphically, okay, when everything is reflected about the y-axis. So previously, I had an asymptote at x equals to 1, so we should expect that to become the asymptote at x equals minus 1, for example, here. Okay, and all our y's, what do you call that, y key points, I guess, like our horizontal asymptote, right, they should be unchanged. Okay, then from here on out is really just reflecting in the y-axis. Okay, similarly for vertical reflection means we are now using our x-axis as our mirror plane. Okay, so it's going to be like this. Okay, this is now going to be our mirror plane. So everything on top is going to be below, everything below is going to be on top. Okay, so again, let's say we had an horizontal asymptote at y equals to 1. This horizontal asymptote is now going to be at y equals to minus 1. Okay, and yes, that's it for reflections. Okay, let's talk about our fourth type of transformation, which is known as your modulus functions. Okay, we're going to keep the same graph over here, and we're going to have two different types of modulus function. Okay, the first one that we have is going to be y equals to mod fx. Okay, so the easy way to remember this is that for y equals to mod fx, we know that we cannot have any negative y values. Okay, so no matter what, we can't have anything below my x-axis. Okay, so we're going to keep parts that are on and above my x-axis. Right, so anything above this line or on this line, we're going to keep as it is. Right, so just copy it straight. Okay, and anything that's below the x-axis is now going to be reflected upwards. So over here, this line in blue, right, is the part that got reflected upwards. Okay, so that's for y equals to mod fx. Okay, for y equals to f mod x is going to be slightly more complicated. Okay, this is going to be split into two different parts. So first of all, we're going to keep all the parts on and to the right of my y-axis and delete everything on the left, right? So we just erase everything on the left hand side. Okay, afterwards, our second step is to reflect this new graph on the right in the line or in the y-axis. Okay, so if you were to look at it here, okay, everything on the right is now reflected to the left, okay, which is the, what I call it, the lines in blue here. So this is my modulus function. Okay, let's take a look at our last transformation, which is known as the reciprocal. Okay, so reciprocal just means 1 over whatever that number is, right? So in this case, it's 1 over my graph, my original graph. Okay, before we attempt the reciprocal type questions, okay, there's going to be some key things that you need to know, right? So here are some features of the graphs, and on the right side, right, is what they become once you perform the reciprocal function on them. Okay, so any x-intercepts are now going to become vertical asymptotes. Your vertical asymptotes are now going to become your x-intercepts. Okay, any y values that you have are now going to be 1 over its original value, right? The reciprocal of itself. So if we had a horizontal asymptote at y equals to 2, we're now going to have a horizontal asymptote at y equals to 1 over 2. So just remember, all y values will become a reciprocal of themselves. Okay, if we had oblique asymptotes, okay, they will now become a horizontal asymptote at y equals to 0. If we have minimum and maximum points, they are now going to swap. So for example here, if we had a minimum point at 1, 3, it's now going to be a maximum point at 1, 1 over 3. Okay, don't forget that, okay, all my y values need to be reciprocals of themselves. Okay, this is usually where people make mistakes already. Okay, and then if you have a maximum point at 3, 5, it's now going to become a minimum point at 3, 1 over 5. Okay, let's take a look at this question from VJC promo. Okay, so here we have a graph of y equals to fx, and they ask us to draw a graph of y equals to 1 over fx. So first off, we need to identify some key points or key features of the graph. Okay, here we have a vertical asymptote at x equals to 2. So I know that this has to become my x-intercept at 2, 0. We have an x-intercept at origin. So we have a vertical asymptote at x equals to 0. Okay, usually if we have an asymptote along any of the axes, we don't really need to draw the dotted lines. But just for clarity's sake, for this example, I am still going to draw my dotted lines here so that you can see where our asymptotes are. Okay, next we have a minimum point at -1, -2. So I know that this is going to become a maximum point at -1, -0.5. Okay, we have a horizontal asymptote at y equals to 0. Okay, so if we have a horizontal asymptote at y equals to 0, basically just remove it. What we do have is a horizontal asymptote at y equals to 2. So this horizontal asymptote is now going to be at y equals to half. So let's draw it here, y equals to half. Okay, so now how are we going to actually draw this graph? This is where most people will actually start to struggle. Okay, all these key points that we have, for example, our asymptote, our intercepts, our maximum points, okay, all of these are meant to guide the shape of our graph. Okay, all we need is a starting point. So let's go in the systematic way from left to right. Right, starting off here, what could this value be? Right, what could this y value be? This y value is very close to 0, right? Because we had an asymptote at y equals to 0 initially. So let's say this was minus 0.000001, for example. Okay, so what would 1 over negative 0.000001 be? Right, you get a very big negative number, right? So on my reciprocal graph, I know that I'm going to start somewhere down here, right? This is a very big negative number. Okay, what's our closest point to this, right, on the right? It's going to be our maximum point. So we know that the maximum point needs to have this kind of shape, right, for it to be considered a maximum point. So the only way for me to ever connect this, okay, is by connecting it like this, okay? And we know that we have a vertical asymptote at x equal to 0. So as my x value approaches this, okay, I must tend towards the vertical asymptote. So here, even without doing much, okay, we are able to draw this left side of the graph already. Okay, so starting from the middle here, okay, what point are we looking at when we are drawing or when we are continuing from this point? Okay, here we have the line x equals to 0, so the point that I'm actually looking at is here. Okay, so what is a y value very close to this, right? So here is a positive value, right? So let's say 0.0001. Okay, so 1 over 0.00001 is going to be a very big positive number. Okay, so we're going to start from up here, right? A very big positive number. Okay, so now the next closest point that we have, okay, is going to be this x-intercept here. Okay, one thing to take note of is it is perfectly fine for me to cross a horizontal asymptote, right? Like doing this here is not illegal at all. Okay, what is illegal is touching a vertical asymptote. Okay, because you need to know how we get a horizontal asymptote in the first place, right? A horizontal asymptote arises, or how we derive it is when x, right, or as x approaches plus minus infinity, right, or in this case it's just going to be positive infinity, right, y will approach 1 over 2, right? This value here is not infinity yet. Okay, so it just means that as x becomes bigger and bigger, right, my y value should tend towards half. Okay, so doing this is not illegal at all. Okay, and over here, the only way for us to draw this, okay, is like this, right? Because you know that it has to tend towards our, what do you call it, horizontal asymptote of y equals to half. Okay, so this is a very short example of how we can draw a reciprocal graph. So y equals to 1 over fx. Okay, So that's all we have for this example, and that's all for transformations. Okay, thanks for watching, and bye bye.